Hey everybody, how's it going? This is Paul, and welcome back to my Philosophy of Science series for scientists, engineers, and researchers. In this video, what we're going to do is talk about what science is, some different ideas. This is called the demarcation problem, or demarcating science from non-science. Now, I'm also going to do another video on pseudoscience, because the demarcation problem is good to give us a general idea of what science actually is, but pseudoscience shares a lot of commonalities between science, and it can be difficult to sort of explain the difference between science and pseudoscience without first talking about what makes science science in the first place. So that's why I'll spend another video talking specifically about pseudoscience, because while science has its own positive attributes, pseudoscience tends to also have its own positive attributes that are defined in relation to science. So it's helpful to talk about science first. Now, for something like philosophy like this, there are two ways you can teach this. There's a historical approach, and this is different than science where you would typically just teach ideas, and maybe you can teach the progression of ideas, but you don't study people. The first way is this historical way where you actually study the individuals who study these different ideas, or philosophers, so you can learn who's building off of who influenced who, these sorts of things. It's a great way to learn. It's the way I think philosophy is typically taught, but it takes too long for the purposes I am trying to do, which is an action-packed best hits, collection of philosophy of science that's useful to scientists, engineers, and researchers. So I'm not going to do that. But if you'd like to do that, the best is Copleston's A History of Philosophy. And if you want a shorter book, you can look at Anthony Kenny's A New History of Western Philosophy, which was him basically trying to take Copleston's approach and shrink it down into one book. And I hear it's very good. I'm only familiar with Copleston's work, and it's amazing. But I've also heard very good things about Kenny, so check that out as well. The other way, and this is going to be the way that I'm going to take, is a conceptual way, where we really talk about ideas and concepts. Now, we will still have to talk about some history, but we'll be tracing the history of these ideas themselves rather than the philosophers or the people. It won't be as much biographical, if that's a word. So my approach is going to be more talking about ideas and who influenced who, but once again, to really get a full picture, you should also study the people themselves, their context, their historical and political context, what sorts of events they were responding to get a full, or I guess fuller picture. So let's get into it. What is science? The main question that we're asking with the demarcation problem is what differentiates science from non-science? And there are a couple of related questions that go along with this, such as, can we create a set of necessary and sufficient conditions for distinguishing science from non-science? But before we even answer or attempt to answer this question, perhaps we should ask an even more fundamental question. I want you to think about this for a second. Why do we care about having a precise definition for the word science in the first place? There seems to be this idea that we want the word science to have cognitive meaning when we're communicating, but there seems to be something a little bit more. That's what I want to explore first. And the reason I say this is people don't see all that up in arms about policing mathematics, philosophy, even engineering. People aren't saying, oh, this isn't engineering. You're working on something that isn't engineering. I've never heard people say this is pseudo-mathematics. I have heard pseudo-philosophy or pseudo-engineering. So what is it about science that the word pseudoscience is such a powerful thing? Or what is it about science that's so polarizing into people accusing each other of pseudoscience? We're going to talk about this first. There are actually political problems behind the demarcation problem that are worth knowing. And if you're in the field of science, if you're a researcher, you are probably very aware of these. The first is going to be power. There are sociologists who have argued that scientists, that us as researchers, have replaced priests as the bearers of truth or representing truth. That's a sociological argument. There's politics. Right? What is considered good science can actually support political agendas, and political agendas can then support certain ideas of research. In the 1980s, Ronald Reagan supported this sort of wedge strategy, or teaching the controversy, teaching intelligent design in classrooms. This is kind of one of the areas in which politics can be involved in science and, has this feedback effect into supporting what public opinion is, especially in a democracy. The biggest one of all, probably funding. What is considered science or worthy of scientific inquiry gets funding for researchers, and researchers are thus incentivized to call other things pseudoscience to get a larger piece of the pot. So basically, if I can claim all the people that are doing work that would be getting funding that I could get, if I call them pseudoscience or they shouldn't get research as a result, scientific funds, now there's more money for me and I can do more of my research. So there are these angles going on behind the demarcation problem as well. This is what Hunter and Nedelisky say in their book Science and the Good. As anyone on the inside of academic life knows, vanity, ego, ambition, intellectual fashion, and political bias play enormous roles in channeling careers and influencing research. They affect who gets funding and from where, who gets published where, and whose reputation rises and whose falls. My claim here is science is patrolled more than other fields because more is at stake. There's more funding, there's public opinion about science, which public, in my view, seems to have a very high view of science. And these journals, obviously, there's reputations involved. So one of the reasons we even care about demarcation, in addition to just wanting to have a definition that's useful, is there are also these political factors as well. So back to the question. Is it even possible for us to answer the question of what science is outside of our own personal interests? Of course, this is a philosophical question, but one that's worth at least sitting in the back of your head, and I want you to remember this as we start talking about these different definitions. Is it possible to give a definition of science that is apolitical or divorced from any political agendas? Do we even need to give a nice definition? Is this even something we should be trying to achieve? This is Lawton, who's a philosopher of science, says, look, philosophers have been unable to agree on demarcation criteria since Aristotle, who is pretty much the first scientist in the Western world. Let's just give up is pretty much what he says. I'm paraphrasing, but that's kind of his point. In this video, what we're going to do is put all these questions aside. Even if the answer to these, let's just assume the answer is yes, even if these are open questions and still worth discussing, and let's just talk about what some of the answers are and what some of the candidates are. Of course, these interests are always present and there for choosing between these different definitions. And of course, if we're going to make a good working definition of science, we do have to be aware that we may have our own biases when it comes to, I guess, defining science in a way that's helpful for us or our own agendas, right? Hopefully we're not doing this, but this is certainly a possibility, is basically the point I'm trying to make. There are two types of definitions that we see in philosophy quite a bit, and this should be familiar for anybody who knows any mathematics. There's our black and white definition, or Boolean definition, which comes from computers, or George Boole, who's a logician and mathematician, which is kind of your idea of black and white, right? You can give necessity in sufficient conditions. It's very binary, very clear cut. You can say if a hypothesis can be falsified, it is scientific. This is both a necessity and a sufficient condition for science that is given, and that's one we'll talk about. Of course, this pushes the definition back a level because we have to assume falsification itself is black and white, but at least this is a step in the right direction for defining science. And the other type of definition we often have in philosophy is a fuzzy definition. This is a sort of general idea. Maybe we can't give a set of necessary and sufficient conditions, but we can get a general idea that's useful for our purposes. And this tends to be what we have in a complex, big field like science. Shades of gray is really the idea of fuzzy, and there's usually more than 50. So, once again, even if there are very clear things like black and white fields that we want to say, these are definitely science, these are definitely not science, or these are definitely pseudoscience, there are maybe going to be some fields where it's unclear. And I'd even argue that's okay. No matter what definition we give, it may not even be possible for us to just very neatly separate every single field from one side to the other. And of course, that will depend on which definition we accept. And it depends on our purpose for trying to choose a certain definition, which is why I mentioned politics in the first place. Let's talk a little bit about controversial fields really quickly, because before I even want to go into these definitions, do we even want or need our definition of science to encompass the rigorous study of things like the supernatural? Maybe if the supernatural exists, it can be studied rigorously, but would we want this to be subsumed under the word science? What about controversial fields like sociobiology, evolutionary psychology, theoretical physics, certain aspects of cosmology? Are these things inventing just so stories, or can their propositions actually be tested or considered just as scientific as something else? These are the kind of questions we need to think in the back of our head when we're leaning towards one definition or another. What about hard versus soft science? Stephen Jay Gould also made a distinction between historical and operational science. If we're doing tests and experiments, we can't investigate the past because it happened in the past. Whereas operational science is stuff like chemistry, physics, we can do it in a lab and these sorts of things. So these are kind of where we get into weird issues, right? Is sociology a science? And if it is, to what extent is it a science in the same way we think of maybe chemistry and physics as a science? Those are the kind of questions that are going on here when we're looking at these definitions. And here's a note to remember, and this we'll talk a little bit more about this later when we talk about epistemology of science, but as soon as science restricts its inquiry to certain methods, assumptions, things like that, it can only produce truth as long as these assumptions are true and its methods are justified. So if we're going to say science is restricted to creating falsifiable experiments, then the methods of science are only going to produce falsifiable theories by definition, and if there are other things that are true that can't be falsified, they're outside the scope of scientific inquiry. Doesn't mean they're not true, just means they're outside the scope of what we have given our assumptions or definitions. And to the extent to which falsification is itself an epistemology, and we'll talk about that later, is kind of its own question once we make these assumptions. And I would argue any such omission of certain fields, these sorts of things, when we say science involves this or that, it's generally practical or political. It's not ontological. It's not epistemic, meaning it has more to do with us wanting a certain definition to be true, us wanting to have some useful way of demarcating science from non-science, rather than it necessarily always being relevant to whether this theory is true or not. So, definition 1, this is the methodological definition. Science is basically the use of the scientific method, which is ask a question, do background research, construct a hypothesis, test your hypothesis with an experiment. Then basically from there, you either falsify your hypothesis or you have evidence to accept it. You analyze your data, you write a paper, you submit your paper to a journal. It either gets rejected or it gets accepted. If it gets rejected, maybe the reviewers have comments, so you repeat this process. And this is kind of how science is done. And if you read any scientific papers, it generally follows this sort of outline. You generally have your abstract, you have your hypothesis, maybe you'll have your background work, your related work section. You'll talk about your experimental setup, these sorts of things. And I think this works very well. It should be clear this is a fuzzy definition though. Some experiments are more expensive, more difficult to replicate. Obviously, something where we're mixing chemicals in a lab is going to be easier to do than falsifying grand theories in psychology or sociology, where experimentation is difficult or there are ethical limitations, things like that, or maybe expensive. You need more expensive equipment for some tests, which of course begs a question: are some fields more scientific than others? Would this mean that psychology and sociology are constrained in their scientificness because they make these background assumptions? And it would seem the answer to this question is yes, if we take this to be a definition. But I don't think that's necessarily a problematic thing. It's just basically a reality of accepting this definition. Also, some theories can't be tested. So here we go, testing with an experiment. So basically there's a degree at which we can say some fields are more scientific in the extent to which they can repeat the scientific method, how closely they can align with the scientific method, these sorts of things. And that's differentiated from what we call just so stories, which is inventing these sort of post hoc explanations of phenomena from observations rather than actually testing them. And that's actually a very dangerous thing, and one of the reasons we want to have a solid definition of science, so we want to be able to differentiate science from just inventing explanations that may work but aren't really true. I think that's the thing we're really worried about with these things. So that's our first definition, the methodological definition. The next definition, which is closely related, is Karl Popper's view, and Popper really says it the best. Insofar as a scientific statement speaks about reality, it must be falsifiable, and insofar as it is not falsifiable, it does not speak about reality. So rather than argue that science tests experiments, Popper says science creates experiments that try to falsify things. And if it holds up to scrutiny, we can be more confident in it. And the analogy I like to give is like a building. You take a building and you subject it to a stress test. And now you can be more confident that your building is a stronger building than one that hasn't been subjected to this. And this gives us a good way of giving certain scientific theories stronger epistemic weight, meaning we can have more confidence in the theories that have been repeatedly tested or tried to be falsified and they haven't been. Now, he gives an interesting example in terms of swans, and he talks about what's called the problem of induction. And he basically gives us this analogy. The problem of induction is this idea of, okay, let's say the sun rises every day tomorrow. Every day. The sun has risen every day. We can assume that happened throughout eternity. Does that give me a reason for thinking the sun is going to rise tomorrow? Or how can I be justified in knowing? And this goes from deductive reasoning, which is logical, to inductive reasoning, which I would argue is a little bit more pragmatic. And this, we see a shift of scientific study or natural philosophy moving from this idea of needing to prove things based on axioms into this more Baconian. It was Francis Bacon who was really wrote down the scientific method in the first way that we see it, to move from deduction, logical deduction, to logical induction, from going from proofs based on premises into assumptions based on repeatability, based on what we've seen, based on past experience. So once again, science really came from these deductive logical rules from Aristotle, who was a philosopher and also probably the first scientist in the Western world. But more recently, in the last maybe 500 years or so, science has moved away from deduction and into induction. Now, induction is going to be weaker and more tentative than deduction. While there have been no, to my knowledge, known accounts that deduction has ever been wrong and produced a contradiction, induction has been wrong. And that's why Popper gives the analogy in terms of swans. In Europe, people thought that there were no such thing as black swans. They'd observed millions of swans for years. All of them were white. There were no exceptions. So people just naturally thought, okay, all swans are white, and that's just a principle. Then this Dutch explorer went over to Australia and noticed, hey, there are actually black swans. They actually exist. We never knew about them. And this falsified this traditional inductive knowledge held for years. And that's why Popper says science can only falsify. It can never prove a positive claim. It can only just subject to scrutiny. Of course, something that withstands many repeated attempts of falsification, I think we should be more trusting in those sorts of things than something that hasn't been repeatedly attempted to be falsified. But that's kind of, once again, the Popperian view. Now, responding to Karl Popper is Thomas Kuhn, who he gives a definition of science, not in terms of falsification, but in terms of problem or puzzle solving. He thought that Popper got it wrong. And if you look at the history of science, what Thomas Kuhn looks at is basically we move around very smoothly, doing just kind of puzzle solving, not really questioning most of our assumptions. And then occasionally we get these huge paradigm shifts or revolutions in scientific theory. And one of the examples he gives is you had Newtonian mechanics. You had this idea of a very law-like universe. And eventually this gave way and it broke, and now you have all of this probabilistic stuff, Einstein's theories, and it's a completely new paradigm. In fact, I think Kuhn was the person who first coined the term paradigm shift. So you have these puzzle-solving periods where people don't really question or try to falsify basic premises, but what happens is people start reporting, just kind of doing their own thing, and they start reporting on these issues maybe with the theory. Now they give an experiment, and there starts to be cracks to the current theory. And these cracks kind of boil over more and more and more until the whole thing explodes and there's a paradigm shift, a revolution that synthesizes all of these cracks into a new theory. And that is the sort of revolution that Kuhn is talking about. Then this becomes the new sort of thing that starts getting its own cracks, and then you have this long period of time as it's gathering cracks and cracks and cracks, and then boom, it explodes. And this is Kuhn's argument that this is how science works. And he gives this quote: "It is normal science, in which Sir Karl's sort of testing or falsification does not occur, rather than extraordinary science, which most nearly distinguishes science from other enterprises." And it's funny, Popper actually wasn't a fan of Kuhn's work. They were both alive at the 20th century, and they went back and forth as to whether astrology was a science, both accusing the other of including astrology, and it's kind of goofy, it's kind of funny, but they weren't really too big fans of each other, even though it's very clear that I think in many ways both of their definitions are very similar in many ways in terms of theories, in terms, I don't mean to put them at odds with each other, because they do have these ideas of really designing experiments and testing. It's just, I think Popper was very restricted to falsification, whereas Kuhn was open to these sort of grand paradigm shifts where knowledge shifts. And that's why it's important to understand both of them. Then we just move on to a fourth definition, which this came about maybe more in the 50s and 60s. And this came about with advances in mathematics, where people became skeptical of their being able to have necessary and sufficient conditions for anything. And this is closely related to things like the incompleteness theorem, where you have these, well, maybe we can't construct this just beautiful, complete set of axioms. And as a result, I think those sorts of ideas spilled into philosophy of science. So here's Pigliucci and Boudry in the philosophy of pseudoscience. He says, science is best considered as a family of related activities with no fundamental essence to define it. So rather than expecting there to be necessary and sufficient conditions, maybe we should just give up on that altogether and instead just generally get some ideas of what constitutes science and non-science. One such idea is what's called virtue epistemology. Okay, that's a big word. Really what that idea is there are certain virtues that make science science. So rather than trying to say this is science and this is not, or here's a law, we instead say science in general aims for this and this and this. And to the extent to which things align with these virtues, they're science, and to which things do not or are against them, those are not science. So these can be virtues of the work or theories themselves, such as falsifiability, testability, maybe the simplicity or elegance of the theories proposed, but also virtues of the researchers themselves, such as open-mindedness, humility, honesty. These things are all necessary for good science, or distinguishing good science from bad science, or science from non-science. Another condition you can have are assumptions, like methodological naturalism. I think that deserves its own video, which is basically the assumption that there's nothing really supernatural or spooky that happens within when you do an experiment. But to what extent can you sort of extend this assumption to all of time, or to time in general? This is once again an inductive problem. And then we get into definition 5, which is pretty much the anything goes definition. And this goes into the influence of postmodernism. Some people, postmodernists, post-structuralists, these guys are going to say, look, science doesn't have any definition. It's just whatever the people in charge, selected as scientists, say is science. There's no epistemic meaning. There's no actual meaning to the word science. Other people would say, no, science is whatever the public thinks science actually is. That kind of creates this maybe collective consciousness. There's no essence to science that can be bundled down. There's a sociological look, which is basically this idea between orthodoxy and liberalism. Now, many philosophers of science will argue that scientific inquiry is a more conservative field than a liberal field, which may be actually surprising. It's very difficult to propose new theories. People are very skeptical. In general, it tends to be very slow-moving. And then, you have these paradigm shifts where things maybe do move very quickly. But for the grand scheme of things, I think if you follow Khun's work, you would be justified in arguing that science behaves more like an orthodoxy. And a sociological look would basically say, no, science is whatever is accepted by scientific orthodoxy. And in which case, for instance, maybe 500 years ago, the idea that the sun revolved around the earth was scientific, not because it was true, but because this is what the scientific orthodoxy believed at the time, or what scientific consensus is. And this gets into, once again, postmodernism and these post-structural critiques of institutions and power. You could argue science is whatever gets funded as science from political institutions. To me, these sorts of definitions are unsettling, but they're worth talking about because this moves into Paul Feyerabend's argument in Against Method, which was a hugely controversial book, and it was pretty much the first, at least from what I understand, the first, if not the most popular postmodern work on looking at science. And basically, Feyerabend argues, and he's familiar with Khun and with Popper, look, science has kind of turned into this thing where each field has its own methods, that they very rarely know what's going on in other fields. These are his assumptions. We shouldn't try to have a method at all. Science should just be a free-for-all. Why try to pin it down? Because he's looking at Khun, he's saying, look, every time we think we've pinned it down, we've been wrong and we've had to revise our theories. So why assume it should be pinned down at all? It should just be basically anarchy. He calls it epistemic anarchy. It should just be anarchy. People should just be allowed to do what they want. And postmodernism would have a lot to say about this too, because postmodernism tends to be skeptical of meta-narratives, the stability of meaning, including hard definitions. So a postmodern look at science is going to reject any sorts of necessary and sufficient conditions at science, and may also look at the individual people as scientists, trying to create that meaning and say, hey, no, you guys have political interests here. You're claiming to be objective, but this is its own political interest. Now, before we end here, I want to talk a little bit about my own view. And this isn't really relevant, but I'll explain why I hold the view that I do. And I'm not trying to convince you that this view is right, but I'll explain why. Now, the definition that I tend to ascribe to most closely is definition 1. And this isn't for, reasons because it's true, because if science is this sort of activity that we as humans have created, then maybe it's evolving, it's an evolving field, maybe the meaning of the word science has evolved. But I like the idea of the science following the scientific method for several reasons. I want the word science to have cognitive meaning and be a useful term. I also want it to be teachable. This idea is simple and it's pretty. It's really an aesthetic argument. I like that I can put this in one plot. I like that it's simple to explain to people. I like that it's a method and not a very super fuzzy idea that we can't grasp or say much about. But these are my own kind of reasons for enjoying it. And the other thing I like is in this way, fields can be placed on a continuum based on how much they follow, or they do, they try to follow, they can follow, or they do follow this particular method. And even individual experiments and papers can be audited as more or less scientific based on the extent to which they follow this ideal method. And last but not least, here's a definition from Adam Savage from Mythbusters. The only difference between science and screwing around is writing it down. Science, you got to write it down so people can communicate. Anyway, thanks for watching. Once again, in that next video, what we'll be doing is talking about pseudoscience and some ideas of what separates pseudoscience from science. Hopefully we'll see you then.